Hello everyone, and welcome back to the channel. I've got something new to show you today. This is going to be a demonstration of a 50 ohm RF digital attenuator, 6 bits, 31.5 dB, and the frequency range is DC to 4 gigahertz. It has an attenuation step of 0.5 dB to 31.5 dB, using 6 independent toggle switches. And we're going to put this together in this little box right here. Again, I like to use these little boxes that are from power supplies for various items. This was a power supply for a laptop computer, and we're going to repurpose it to put this little attenuator in the box, powered by a 9-volt battery that is rechargeable, by the way. Right there, it has the USB-C charging port on the battery. This attenuator does use 3.3 volts of supply voltage, so we have to bring this down to that value, 3.3 or 3 volts. And we're going to do that with this Zener diode, a 3-volt Zener diode at a 100 ohm resistor. So that's what we're going to do. We'll put this all together and we'll demonstrate this in a part 2 video. So basically it's going to go like this. We're going to take the box, flip it over, and we're going to put the attenuator right here. Let's see, it's going to fit right here, and there'll be a screw holding it through with some standoffs to the other side of the case. Battery, let's see, the battery, I think we're going to put that right here, and that'll go right in this position. And then of course the attenuator switches, I've already pre-drilled the holes, 6 switches, and there'll be a on and off switch right here. Let's see, right there, on and off switch. And then the reason why I took the SMA connector off of this end here is we're going to extend it, put it on a piece of coax and extend it into here, and something like that. That will give us our input to the attenuator, and a piece of coax going here to the output. So that's the plan. We'll see how it goes. Before we move on to part 2, I'll just kind of give you an idea. There is a data sheet that you can download. It's a Peregrine, or I don't know how you really pronounce it, Peregrine, PE 4302. This is obsolete. There is a replacement for this that is a PE 4312. It's a direct replacement, has a little better accuracy specs and a wider DC supply voltage range. I believe it goes higher than the 3.3 volts, which is recommended maximum on this one. So it's not a showstopper for me, but I haven't seen any of these little attenuators with that new chip in it. So you could put it in if you wanted to. To me, it's just not worth it here. So some of the interesting specs on it here, I put on a different sheet. And here we go. So if you look at it here, we have insertion loss of 1.75 dB. It goes into compression at 34 dBm. That's far above the maximum recommended input from DC to 4 gigahertz plus 24 dBm. So we're not going to hit compression with plus 24. Voltage range 2.7 to 3.3 volts. And we're going to set it for 3 volts. And the maximum current draw at 3.3 is 100 microamps, very low current. And I did measure 13.8 without any attenuators active. That's kind of it. Here's the truth table. You have 6 switches, V1, V2, V3, V4, V5, V6. And that's the truth table. It shows you when each switch is activated, how many dB that will be applied to the attenuation. So there we go there. So without further ado, let's put this thing together. Let's go to part 2 in the video, and we'll give you a quick demonstration there of how it works. Thank you. See you on part 2.